Today, I'm going to show you how to build a really simple RAG AI agent in N8N, where you can easily talk to all your data. And I'll show you how you can sync content from your Google Drive to a vector database so that your agent can retrieve information from it and answer your questions. You'll be able to get all this set up in less than 10 minutes using the free templates I'm providing. And you can get these by just signing up to my email newsletter. I'll leave a link below. All you need is an N8N account for the agent and the sync automation, and a free Supabase account for the vector database, and a Google Drive account to drop your files into. You could also use any other cloud storage service. It would just need a bit of tweaking in the automation. So this is the RAG agent. It's a very basic AI agent setup. RAG, by the way, if you didn't know, stands for Retrieval-Augmented Generation. So it will use a vector store tool to search for relevant information, and it will insert it into the context window, and it will use that to craft a more accurate response using data that is contained within the vector store. A vector store is like a giant 3D library where there's lots of chunks of data in there that are arranged by semantic meaning rather than by strict words. So cat and dog and snake would be in a very similar cluster of this 3D space, whereas tree might be a bit further away and library would be elsewhere. I hope that makes sense. Explaining that in any more technical detail is way above my pay grade. So anyway, in this agent setup we have chat input, which goes into the agent. The agent has a very simple prompt. This took me 30 seconds. You are a helpful assistant with access to a vector store tool, which you can use to get information. Do not guess or make anything up. Use the tool to get the right information to answer the question you've been asked. And the agent obviously has a chat model attached, which is just GPT-4o, which is what I use in all my agent builds. It has Postgres chat memory, which I've shown how to set up in another video. It's just using Supabase to store past conversations so that it knows if I refer back to something I said a few messages ago, it can access that and it can answer it more accurately. And then we have the vector store tool. So this is just a simple, a very basic description here. It gets all available knowledge, and the real setup is down below. So we're using Supabase as our vector store. There are other ones such as Pinecone out there, which is a very popular one. There are some subtle advantages and disadvantages to each one, but I've just started using Supabase for all of mine now. The first thing you have to do is get Supabase set up in order to kind of establish a vector store. So N8N has some very good documentation here. So if you go into the Supabase vector store node and click on docs, you come to this page here, and then we've got a quick start for setting up your vector store. So open this, and all we have to do is copy all this. This is a bunch of code that I do not fully understand. And you go to Supabase, go to SQL editor, paste that all in, and hit run. And we've got an error. I think this might be because I've already done this, and it says extension vector already exists. So I think if I just comment this out and try and run it again, function match documents already exists. Okay, one sec. Okay, so I'm just going to create a new project. We'll just call this N8N02. I'll just type in a password. I'll go for London because I'm in London, and that should do. Okay, so I've just created a new project called N8N002 because I'd already done the database initialization step previously, and there were some issues with the code that I don't fully understand, so I thought it'd be easier to just set up a new project. And that's what you'll have to do anyway if you're doing this from scratch, so it'll make it a bit more easy to follow along. So let's try SQL editor again, and we'll go back to here, copy this code, paste that in, and let's try running this. Success. Okay. So that's all done, and now we have a table called documents. So we're going to use that in our Supabase vector store. So if we now go to our table editor, we can see we've got a table here called documents, and it has ID, content, metadata, and embedding. So this is set up to be a vector store. So now let's go back into our agent and to this node, and then we're going to create a new credential. So here you have to go back to the dashboard here and take your project URL and the API key and copy and paste that in. So that's done. And then we just select documents from this list. And then we're good to go. So now the agent can access this vector store called documents, but there's currently nothing in it. So let's save this and let's look at the next step. So this is the syncing automation, which does two things. It watches this Google Drive folder for files created and for files updated. So this, for instance, will watch every minute for changes in this folder, and this will do the same thing for files updated. And then here we're just getting some information from the metadata from the Google Drive node. So we're just capturing the file ID, created time, modified time, and the is trash. Up here, if the file ID, we're basically going to delete any file that has this file ID. So if it's an updated file, firstly we want to delete it. So then we can create a new one in its place. And then it will download the file using the file ID from either of these two, whichever one this comes from, because we're setting the field here, it's the same. So this is just taking the file ID from this node, and then we're going into the Supabase vector store, and we're using match documents. So in the default data loader, we are setting the file ID as the file ID from the set fields node earlier on. That means that the file ID within the vector database is going to be the same as the file ID from the Google Drive. So that means that the previous delete row node here will work because it's able to look up the file ID correctly. And we're using the text embeddings 3 small model for the embeddings from OpenAI. And here we're using a recursive character text splitter, which just means that we're going to upload a chunk size of 1000, which means it will split the documents into chunks of 1000 tokens. And actually we want to have an overlap here because I think it's important to have an overlap, because if you have if you just take the first 1000 tokens and then the second 1000 tokens, there could be a scenario where a very important bit of data gets split up. So from 995 to 1010, there's a really key sentence, which is the data that you want, that will give you the answer to the question. But then that will be split up into 2 separate things, so you can't actually get the full context of that. If you use a chunk overlap, it will take one chunk is 0 to 1000. The next chunk will be 900 to 1900, etc. So it just makes sure that you've always got the full context. And that's that. So that will then take the files, either updated or created from the Google Drive, upload them into the Supabase vector store that we can then query. Okay, so let's upload some files. I got ChatGPT to create me 5 job specs for an emerging AI company, just as an example for this. So you can see some, it's the very simple data in there, bit of information on location, salary, qualifications, responsibilities, etc. So we have put them in this demo documents thing, which means that hopefully this workflow should have triggered. So it runs every minute. So let's keep watching, and there we go. So this workflow here is running, and we'll be able to see it once it's finished, and we'll see what it's done. So it's seen file created, it's set the fields, it's cleared any existing data. There's 5 items here, so it's run them all through. Added into the vector store, and done all this fancy stuff down here. If we go into Supabase, and if we go to the table editor, documents, here's all the chunks of data. So you can see basically there's 5 different sets of data here that have been split up into chunks. So we will now be able to query these using our RAG agent. So let's try this by chatting to our agent. Okay, are there any jobs available in London? If so, what is the salary? So you can see the agent is using the vector store tool, it's using the OpenAI chat model. There are job opportunities available in London. One such position is for an AI research scientist, which offers a salary range of £70,000 to £100,000. So if we look here, there we go. It's used the vector database. It's found semantically the correct information to bring back. It's then inserted that into the context window, and it's been able to answer our question. Again, this is a really simple example of the kind of things you could do, but imagine if you had like thousands and thousands of documents on all your company data. If you're a recruitment agency and you had 2,000 open jobs, you could give the agent a CV of somebody and say, what are the top 5 jobs that this candidate is qualified for? That kind of thing. We could then also ask, what are the requirements for this role? And you can see, because it's using the Postgres memory, I didn't say what are the requirements for the job that we talked about before. It's using the memory so it can recall that information and then give me a relevant answer to the query. If there was no memory here, it would ask me, what role are you talking about? And if you look at the logs, you can see every step that the agent took, and I'll try and give a very rough approximation of what's happened. I'm not very good at explaining this stuff, but basically the agent's accessed the memory to get the previous conversation that was just had. Remember, the query here was, what are the requirements for this role? So it's using the memory to get this, and then it's using the OpenAI chat model, and this is the entire context. So you've got the system message here, and then it's used the memory from the previous step to insert this previous conversation here, and then it's included the recent query that says, what are the requirements for this role? And then it's used the vector store tool, and the agent has taken this information, and it's put it together to ask the tool this question: what are the requirements for an AI research scientist role in London with a salary range of £70,000 to £100,000? So that is, the agent has taken all this information and used it to generate a query to ask the vector store tool. And then it gets this information back from the vector store. It's found the most relevant information in there, and it's returned it in context. So it gets all this stuff. And then this is the call to the model that the agent is using. So you can see the full thing now. So that's the system prompt. This is the conversation, and then the AI used the tool, and the answer from the vector store was, these are the requirements for this role, here it is, and then the output is to the user, a nicely formatted answer to the question. The requirements for this role are this. I really hope that made some kind of sense. So that's how you make a simple RAG agent with data synced from Google Drive. As with all my workflows, this isn't designed to be the finished product. It's more like a way of showing you the framework of how you can build things like this. Obviously, you'd want to spend more time on the prompt. You want to give it all your correct data. You also might want to give the agent more tools. You might want to build things that auto update the data in your database every day or every week, so that you've got a constantly up-to-date set of information that your agent can answer questions on. If you want the templates for this build, as always, they're available for free. Just sign up to my newsletter. There's a link in the description below. I really appreciate everyone that's watching my videos, and hopefully you're getting value out of them. As always, if you've got any suggestions of things you want to see built in the future, let me know. I'm always open to hearing suggestions. So thanks for watching. I'll see you next time.